So our last example talks about the intensity of the sound of a bell. So you know when a bell gets gonged, it makes a big, loud, deep noise. But then as time goes on, that noise gets less and less and less. It's just fainter and fainter and fainter. It's not like the pitch changes, but our ability to hear it changes. So if we're looking at this graph represents we started off at time of 0, and then each second that went by, you see this drop in the intensity of the noise, and then it kind of evens out. So for this graph, what does the y-intercept represent? Well, if we're looking at what the y-axis is reporting on, it's the pressure in pascals. So that means any number along the y-axis is talking about pressure. So the y-intercept is 200 pascals, and it represents the initial pressure intensity, like sound intensity. And I would like, as a teacher, I would accept the words, oh yeah, it's intensity, instead of talking specifically about pressure, because that's how you would make sense of this question. It's how well you can hear the bell, how loud it is compared to how faint it is. So even though it's talking about pressure, that's what sound waves actually move in. They're measured in pressure, because that's how the waves move. So then it wants to know, what is the pressure after 2 seconds? Well, I can look at the graph and I can get a pretty good idea. Like, this looks really good. This looks like 50, but that's me eyeballing it. That doesn't mean it's exactly 50. So we get a rough estimate. We should get an answer that's around 50, but we have to use this equation, and we're going to have to plug in a time of 2. So the pressure is going to be 200 bracket 0.5. And remember, 0.5 is the same as 1/2, which means that the base of this exponential graph is a fraction, which shows that it's decay. So all of that makes sense. All of the rules are going through the way we would want them to. And then remember, if we're raising to an exponent, you've got to use the little hat button. And we are going for 2 seconds. So 200 bracket 0.5 close bracket raised to the 2. I got 50. Okay, so we did get the right answer because this is a pretty fantastic graph and it was easy to read. But if the answer was 48, you see how it looks like pretty close to 50. So you always have to double check with the calculation if you can. So after 2 seconds, the sound pressure was 50 pascals. Then they want to know, after 9 seconds, same idea, wherever we see the T in the equation, we're going to replace it with 9. So pressure, here's our equation, 200 bracket 0.5 close bracket raised to the time, but they told us 9 seconds, so we're going to replace that. 200 bracket 0.5 close bracket raised to the 9. Ooh, I get 0.3900625. So I'm just going to write that as 0.4. Therefore, after 9 seconds, the sound pressure was 0.4 pascals. Nice.